I'm going to go over quiz number 3. In the quiz number 3, problem 1, this is quiz 3. The problem 1, I give you one vector, I call x, and I give you the vector 2, I call it y, and I give you vector 3, I call z. Vector x, if you put a ruler, you're probably going to get, I don't know, 3 centimeters. If you put a ruler, it looks like 1 centimeter. If you put a ruler, it looks like 1 centimeter. But it doesn't matter. I'm going to show you in a second how to do it to this scale. But I'm just giving you an idea. I ask you to find the total displacement. So if this is a vector, this is called tail, and this is called head. So you're going to use head and tail method. Head and tail method tell us that you can add vectors. So this is vector 1, this is vector 2, this is vector 3. Okay, we're going to put vector 1, x, and then we're going to put vector 3. The tail of vector 3 is going to come to head of vector 1. Okay, great. So if this is 3 and this is z, if this is 3 centimeter, this is 1 centimeter, and together this is 4 centimeters, which is okay, it's fine. And now we're going to finally take care of this one. This is 1 centimeter. Now I'm going to call this one displacement because it is displacement. We don't have to do this way. We can also do this way. Both way, you get the same answer, right? So if this is 4 and this is 1, you can get 4 square plus 1 square. I don't know, this is probably 4, I don't know something, but this is just an estimation. Let's take you to the quiz 3, and I'm going to show you how to use the ruler to do that. Let's start the quiz number 3. I'm going to call it key. I'm going to measure, as you saw on the board, I can use the head and tail method to add the vectors. I can move the vectors using head and tail. So the displacement is initial position to the final position. You connect it. Never forget to put an arrow. Okay. So you can measure this one. That is 4 centimeter. I give you 1 centimeter is equal to 5 meter. So 4 centimeter times centimeter cancel. This is meter. 1 centimeter is 5 meters, centimeter cancel, 4 times 5 is 20. How can you verify it? Well, you can verify it by using Pythagorean theorem. This is 2.8 centimeter. This is about 1 centimeter. This is also 1 centimeter. So this is 2.8 centimeter. This one is 1 centimeter. So 3.8 centimeter. This is 1 centimeter. Okay, so this is Pythagorean theorem, 3.8 square plus 1 square, which is probably 4. 3.8 square plus 1 square, which is 4. So you can do, you can check your measurement. Okay, so the answer is 20. 20 plus minus 1, of course, because this is, you measure it. 20 what? Meter. Mr. Bari drops a ruler. So when you drop a ruler, right? So I'm dropping a ruler and Isaac catching it. So let's see. Isaac catching it like this. Okay. This is how you can do the undistracted reaction time. So then what happened is D is equal to VAT plus half AT squared. When you drop it, initial velocity is 0. This is 0.3. Where does 0.3 come from? 0.3 come from is 30 centimeter. Half negative 10 t squared. So then 5 t squared is equal to 0.3. T squared is equal to 0.3 divided by 5. T squared is equal to 0.06. T is equal to 0.2449. Let me see, verify this. 0.3 divided by 5. 0.06 is square root of 0.06 is 0.2449. Okay, now you are driving. All right, all of a sudden you see someone passing the road. You are sending the decision from your brain to your foot. Why is that? So you can hit the brake, and that time is not 0. That time is 0.2449. 0.2449 seconds it takes for Isaac to send the information from brain to foot. So location A to B, acceleration is 0 because he did not have chance. His foot doesn't know what his brain knows. All this crazy, but anyway. His brain knows 0.2 seconds later. His foot knows 0.2 seconds later. Oh, it's a philosophical. Anyway, so this says after this there would be acceleration which is negative. So the car slow down and hopefully stop here. But that's another story. So d is equal to VAT plus half AT square. So this is 0. Acceleration is 0. Now another thing is the car is moving 50 miles per hour, and 50 is about 22 meters per second. You can convert it. In fact, I'll show you. 50 miles per hour times hour has to be cancelled. So this is kilometer. 1 mile. 1 mile is mile. Am I tired? 50 miles per hour. Mile cancel. So this is kilometer. 1 mile is 1.6 kilometer. Kilometer is not SI unit, so meter. Kilometer cancel. 1 kilometer is 1000 meter. Hour cancel. Second is SI unit. 1 hour is 3600. So hour cancel. Mile cancel. Kilometer cancel. You have 50 times 1.6 times 1000 divided by 3600, which is 22, and you have meter and you have second. Okay, so what does that mean? That means 22 times 0.244 is about 5.2. 22 times 0.244 is 5.4. So 5.4 meter. He moved 5.4 meter. He moved from here to here. The distance is 5.4 meter. Okay. All right. So this is east. This is west. Acceleration and velocity at the same direction, so it's speeding up. Acceleration and velocity to opposite direction, so slow. Acceleration and velocity opposite direction, slow. Acceleration and velocity same direction is speed. Out of 4 scenario, 2 scenario, the object is speeding up. Here I have, this one is just from 0. Make sure if you don't see it, you ask me. Okay, so this cover 1 meter, this covers 0 meter, this cover from 1 to 5, 4 meter, this cover 5 to 6, 1 meter, this cover 6 to 2, so -4, 2 to 1, so -1, 1 to 1, 0, 1 to 0, -1. So total distance is 1, 4, 5, 9, 10, no, 1 plus 4 is 5, 6, 10, 11, 12. Total displacement is 0. Why? 1 plus 4 is 5, plus 1 is 6. -4 minus -1, -5, -6. Positive 6, -6 is 0. Okay, 12 meters, 0 meter. Okay, now we're going to do this one. Every interval is 2 seconds. 0 to 2, 2 seconds. 10 to 12, 2 seconds. I have how many sections? 1, 2, 3, 4, 5, 6, 7, 8 sections. Well, section is not important today because I give you the time and I ask you what would be the position at this time, what would be the velocity at this time, what would be the acceleration at this time. So section is not important. Section is important to convert it to dt to vt. I was very generous in terms of grading. Next time on Friday, I will not be generous. 1 divided by 2 is half. 0 divided by 2 is 0. Here, you cannot say 4 divided by 2. No. because this is not linear. So how can you deal with this? This must be triangle. Why? Because this is a positive card. So half BH. Triangle means half BH. So 4 is equal to half 2H. So 4. So this one go all the way to the 4. Okay. So this area is 4 now. Okay, the next area is 1. So you're gonna fall, well, let's see where you're gonna have to fall. I think you're gonna have to fall to 1. 1 is equal to half 2H. What a coincidence. I have to have something underneath. Otherwise I cannot write. Okay, the next one is, the velocity over here is 0, so you connect them. The next one is -4, so -4 is equal to half 2H. So this is -4. -4 is all the way over here. The slope is very sharp. The next one is -1. So go to all the way over here, and the velocity is 0 over here. Connect. The slope of this one is 0. The slope of this one is -1 divided by 2, -half. You're done. You're gonna shade it. Shading takes almost no time. You're gonna write 1, you're gonna write 0, you're gonna write 4, you're gonna write 1, you're gonna write -4, you're gonna write -1, you're gonna write 0, you're gonna write -1. If you don't write it like this, then I'm sorry, you're not gonna get you're not gonna get credit, because it takes lots of time to grade. The slope of this one is 0. Okay, so this is 0. The slope of this one is 0. The slope of this one is 4 divided by 2, which is 2. The slope of this one is -1 divided by 2. The slope of this one is -4 divided by 2. The slope of this one is +1 divided by 2. The slope of this one is 0, and the slope of this one is 0. So let's make it nicer. Okay, you don't have to shade area under the curve. No shading. No, not this one. Okay, write the average speed. Okay, average speed is distance over time, so 0.75. Find the acceleration 5.5. Go to 5.5. Where is 5.5? 5.5 must be between 6 to 4. Very close to 6. Where is 6? This guy is 6. So very, very close to 6 is 5.5. But you're looking at the wrong graph. This is position function. This is velocity function. This is acceleration function. You must look at this graph. So this is the same graph. All right. Okay. So if you look over here, what is it? 2. Acceleration is 2. Okay. Velocity. Okay, velocity at 4.5. Now 4.5 is also between 6 to 4. What is 4.5? Let's see 4.5. So 4 to 6 is, this is 4 to 6. So 4.5 is here. So I want the velocity right here. It's called instantaneous velocity. It doesn't matter what you call it. Just find it. How are you going to find it? You can look it over here, but that's not reliable. So you have, this is 4.5 is between 6 and 4. So 4 comma what? 0, and 6 comma what? 6 comma 4. So you have many ways to do it, but I'm going to do it this way. VF is equal to VI plus AT. Acceleration at 4.5 is 2. Acceleration is 2. T minus. I'm going to write this equation as this, t minus tf. When the time is 4, the velocity is 0. At 4 seconds, the velocity is 0. So if I write, look at here, if I write 0 here, if I write, this is time. If I write 0 here, I have to write 4 over here because this is 2, this is 4. What does that mean? At 4 seconds, the velocity is 2. Velocity is 2 at 4 seconds. No matter how you say it, it is what it is. 2t minus 8. Okay, now you say this is your velocity function. Now you can say 4.5 is 2, 4.5 minus 8. Now you can say 9 minus 8. So this is 1. Okay, now we found it. Now position is at what? 5 seconds. At 5 seconds, 5 is where? Where is 5? 5 is also between 4 and 6. Look at 4 and 6. So this is 5. So this is 5, okay? So over here, you want to find what is the location of the object right here at 5 seconds. At 5 seconds, you can see it from here, but this is not reliable because it's not drawn to the scale. Okay. So now instead of this 2 point, 4, 0 and 6, 4, because these are velocity, at 4 second velocity is 0, at 6 second velocity is 4. We are not dealing with that. We are dealing with now position function. So 4, what is the position? 1. 6, what is the position? 5. 4, 1, velocity is 0. So velocity is 0. Right here you can be able to draw a tangent line. So that means this is h and k and this is x and y. So y is equal to m x minus h square plus k. So y is equal to a. Y is equal to 5 is equal to a. X is what? 6 minus h is 4 square plus k is 1. So 4 is equal to a, 4a. A is equal to 1. Okay, good. A is equal to 1. So you're going to write that y is equal to a x minus h square plus k. So y is equal to 1 x minus h. What is h? H is 4 square plus k is 1. This is the equation. So now you can write p of t is equal to t minus 4 square plus 1. And at t, when t is 5, then you write p of 5 is equal to 5 minus 4 square plus 1. So p of 5 is 1 square plus 1, which is 2. So this is 2. We're done. Now the motion of the y direction. You are 60 meters above the ground throwing something at 90 degrees with respect to the ground. In fact, this is not ground, this is your rooftop. The ground is here. You are 60 meters above the ground, that's why I call it negative 60. You calling this one 0, 0. Velocity is 20. What does that mean? Velocity y direction is 20. How can you write it? Velocity initial x, velocity initial y. Velocity initial. Instead of x, you can write cosine theta. Instead of y, you can write sine theta. Velocity initial is 20, cosine 90, 20 sine 90. Cosine 90 is 0. So 20 times 0, which is 0. Yeah, that's true. When you throw up something like this, velocity at the x direction is 0. That's why it didn't move to the x direction. Sine 90 is 1. So 20 times 1 is 20. That's correct. When you throw something at 90 degrees with respect to the ground, which is the table, then 100% the velocity is at the y direction because you throw it at 90 degrees. Okay, great. That's out of the way. Now, What is the vertical velocity of the ball? See, this is location 1, this is location 1, this is location 2, location 3, location 4. Location 1, nothing going on except the initial velocity. Location 2, you can draw a tangent line. What does that mean? The object changes the direction. Object changes the direction at the max height, which is 0. So velocity at the max height is 0. So what is the vertical velocity? 0, which is 2. Someone wrote 0, and that's not what I asked. 0 is option 2, so write option 2. What is the acceleration? Acceleration at the top, acceleration everywhere, acceleration due to gravity everywhere. Acceleration over here on this calculator is -10. Otherwise, this one gonna float in the air. So acceleration due to gravity everywhere is -10. Even when you're sleeping, when you're walking, when you're not walking, when you're not talking, when you're talking, when you, I don't know, when you're doing something, when you're not doing something, it's always -10. The job of acceleration due to gravity is keeping you to the ground. If it is not -10, then it cannot keep you to the ground. All right, so it's -9.8, which is option 2. Okay, so the ball's vertical velocity at location 3. At location 3 is the same height, so you can cut. If this is called axis of symmetry. Axis of symmetry, cut the parabola in half, and the gravity works symmetrically. Okay, so if it is 20, this is -20. If it is 10, this is -10. Okay, so you can say this is -23. The total distance, in order to find the distance, we're going to find the time. Time is 0. We're going to find time here, and time here. So we're going to use a brand new thing. So time 1 at location 2, VF is equal to VI plus AT. Let me see my recording working. Yeah. VF is equal to VI plus AT. So VF is 0 over here. So 0, 20 minus 10t. So t is equal to 2. If the time is 2 over here, time is also, if from here to here is 2, here to here is also 2. So I'm going to write 4. I want to find the time over here from here to here. So d is equal to VAT plus half AT squared. So this is 60. Why 60? Because this is from here to here is 60. This is 20t plus half -10t squared. Acceleration due to gravity is -10. I ask you to use -10. Please follow the instruction. 60 is equal to 20t minus 5t squared. 5t squared minus 20t minus 60 is equal to 0. Divide everything by 5. T squared minus 4t minus 12 is equal to 0. So minus b plus minus b squared minus 4ac over 2a. So you have 4 plus minus 16 minus 4c is -12. 2. So 4 plus minus 64 over 2. So 4 plus minus 8 over 2. So 4 plus 8 over 2, 4 minus 8 over 2. This is no good. So 12 over 2, this is 6. So the time over here to 6. So now you know everything. This is 20, this is 2, this is 4, this is 6, this is -20. You're going to have to find this one. To find this one, VF is equal to VI plus AT. VF at location 4, VI is 20 minus 10. Time is 6. So 20 minus 60. So this is -40. Okay, now we're going to find the area of this. A1 is triangle. So half BH. So half B is 2 and H is 20. So this is 20 meter. A2, half BH. So half B is 2. 4 minus 2 is 2, and H is -20. So 2 to cancel, this is -20 meter. A3 BH. So B is 6 minus 4 is 2, and H is -20. So this is -40 meter. And A4 is half BH. So half B is 6 minus 4, and H is, this is -20. So 2 2 cancel, so this is negative 20 meter. So distance is 20 plus 20 plus 40 plus 20, which is 100. Displacement is 20 minus 20 is 0, minus 60 meter. So the total distance is 100 meter. The velocity, impact velocity, what is the impact velocity at location 6? Negative 40. Find the average speed. 100, average speed is 100 divided by 6, which is 16 or 17. Find the area 1. Area 1 we found it, which is 20. Area 3 we found it, negative 40. Find area 4, which is negative 20. Draw the line. Okay, so acceleration is constant here. Acceleration is constant from t is equal to 0 to t is equal to 6. What is that constant acceleration? Negative 10. So we can use average velocity is vf plus vi over 2. What is vf? Negative 40. What is vi? Positive 20. So negative 20 over 2. So negative 10. Magnitude, positive 10. Positive 10. Draw negative trend. So this is your average velocity. Alright, that was the test. I just finished tutorial for quiz number 3, and the exam 4, 90% exam 4 gonna be based on quiz 3.